So here we are for the long-promised explanation of how the multiverse is testable. Now, in previous episodes, I have actually explained certain ways in which the multiverse is experimentally testable. But today, I'm finally going to get to David Deutsch's own experimental test of the multiverse interpretation versus all those other kinds of interpretations of quantum theory, namely the ones that involve so-called collapse of the wave function, so collapse models. Now, the way in which I'm going to explain this experiment is not by simply reading David's papers that he's written on this, or even going to some other popular accounts of it, but rather I'm going to try and turn it into a story. And the reason for doing it this way, the reason for telling a story, the story of the experiment, is the experiment isn't practically feasible right now, but it will be one day. So it's kind of like how the Higgs boson, this particle that gives other particles mass, was postulated long before there was an actual practical way of testing. It took the Large Hadron Collider, a piece of scientific apparatus much larger than anything else that had gone before. It took decades before the hypothesis of the Higgs boson could be tested by experiment, or rather, before the theory of the Higgs boson could be tested by experiment, namely the Large Hadron Collider, smashing particles together and seeing what came out and seeing if we could actually observe the Higgs boson. Of course, as Popperians, what we say is that we weren't confirming the existence of the Higgs boson, we were refuting all the other ideas about what those observations could mean, namely if the Higgs boson was some other kind of particle. So every other theory about what was going on in those experiments was refuted, but the Higgs boson explanation of the observations was not refuted. And so therefore we say that those experiments from the Large Hadron Collider did indeed reveal the existence of the Higgs boson. All right. So now it's story time. This is a science fiction story. So perhaps sit back, get yourself a nice cup of tea, and enjoy being transported to the future. So picture it. It's the year 2075. And though quantum computers are now carried in the pockets of most people, David Deutsch's proposed test of Everettian quantum theory against other so-called collapse models has yet to be performed. Many artificial general intelligences actually now populate the Earth. And while many silicons, as the new general intelligences are happy to be called, choose to house their minds within bodies that closely resemble those of typical humans, others choose to take the form of cars or aircraft. Some few even choose bodies that double as spacefaring vehicles, because without the need for oxygen, or indeed air of any kind, they can routinely explore the darker reaches of the solar system, just for fun. Some of these intelligent spacecraft are very large indeed, as they may carry huge payloads of batteries, and some also choose to be employed as cargo vessels, shipping resources between Earth and other bodies in the solar system. Now, one of these space silicons, and the hero of our story, is called Parlock's Cubite. Parlock's has what in the year 2020 would be regarded as a very unusual body for a person. He has the shape of a very long, about 100 meters, and very wide, let's say about 50 meters, box, which is not very deep. It's only about 5 meters deep. So this is his body. His body is a box. This is useful for carrying cargo. Only a small portion of his body houses batteries and a landing gear and rocket fuel for landing and takeoff. Parlock's can land in any number of configurations and generally takes off in such a way as to minimize his cross-sectional area and reduce air resistance on low-gravity moons. He's an explorer, this Parlock's. He likes to move between places in the solar system that no one else has been to before. And so this is why he's chosen the body that he has. Now, on a particular day, somewhere in 2075, Parlock's is travelling from Earth to Jupiter's moon Europa. It has long been known that the radiation saturating the surface of Europa from Jupiter is too intense for any regular human to endure. So despite many probes over the years visiting the moon, few people, and no manned missions, have ever landed there. Parlock's is a physical chemist by training and wants to investigate the ocean beneath the ice on the surface for signs of life. So far, no other missions have found any evidence at all. The journey to Europa is 2 months long, and though he could enter a kind of hibernation state, most silicons have found, for reasons yet to be known, that the hibernation state tends to cause uncomfortable nightmares about 3 days in, and terrible dizziness upon waking. For this reason, on long journeys like this, Parlock's chooses the best known sleep-awake cycle. Sleep 7 hours, wake 7 hours, sleep 9 hours, wake 9 hours, repeat. He also has a list of tasks he's set himself to keep himself occupied. One item on the list that he's particularly excited about refers to a message in his ongoing correspondence with the now 122-year-old Professor David Deutsch. Parlox asked whether he might be able to conduct an adapted version of Deutsch's test set out in Section 8 of his 1985 paper, Quantum Theory as a Universal Physical Theory, as published in the International Journal of Theoretical Physics, Volume 24. David and Parlox plan to co-author the paper, in which the results will be published and finally perhaps putting to rest what they regard as almost 150 years worth of nonsense in the foundations of quantum theory. Parlox's huge body is, right now, empty, and an almost perfect vacuum isolated from any other matter as it travels through the emptiness of space. But inside his cavernous body is one of the most perfect Mach-Zehnder interferometers ever to have been created. The half-silvered mirrors, near perfect. The laser, perfectly able to attenuate the beam down to just 1 photon each microsecond, second, or even hour if you like. The detectors, the most sensitive ever created. There are 2 regular mirrors in the experiment. Regular except for one thing. These mirrors are directly wired to Parlox's mind. So I'll just say that again. These mirrors that are inside Parlox's body are directly wired to his mind, much like the retinas in our eye are directly wired via the optic nerve to our brains and our minds. So Parlox has a very special sense organ. Parlox can detect the slightest vibration of these mirrors due to a collision with something as small as a single photon. Parlox has a mind running on a brain with switching speeds as fast as the speed of light, as all AGI in the year 2075 do. And so he is able to record and transmit data at this speed. Now, I've got a schematic here, a picture of the internal workings of Parlox's sense organ that is the mirror setup. As we can see, the inner workings of this particular organ, if you like, in Parlox's brain are very similar to the Mach-Zehnder interferometer. So we've got some source of photons, the half-silvered mirror, where the beam will be split into an up part and a down part. That's the U and the D. The regular mirror there is Parlox's sense organ. It connects that regular mirror via some cable, some wire, some nerve off to Parlox's mind. A similar thing with the other regular mirror that is on the down part. And then, as usual in the Mach-Zehnder interferometer, we've got a couple of detectors there, detectors 1 and 2. Now, Parlox has carefully set up the lengths of the U, the up path, and the D, down path. According to collapse theories, like the Copenhagen interpretation, indeed, according to any interpretation that is not literal quantum theory, saying all possibilities really do exist, namely a multiverse, when a photon is emitted at the source, it makes no real sense to ask which of the paths the photon takes. It simply has a 50% chance of going along the U path and a 50% chance of going along the D path. If no one observes which of these paths it goes along, then the photon will be detected with 100% probability at detector 1 and 0% probability at detector 2. This is because of how Parlox has set up the experiment, namely by ensuring that the path length of U and D is slightly different, but the details do not matter. And I've mentioned this in an earlier episode as well about the details of how the Mach-Zehnder interferometer works. What the collapse interpretation says, as do other interpretations, is that some sort of interference effect has happened, and that when the photon is finally detected at detector 1, all the possibilities have collapsed into 1. But what the collapse theory also says is that if anyone were to observe the photon mid-flight, for example, if they knew it was travelling along the D path and not the U path, then the interference effect would be destroyed, and we would have 50% of the photons going to detector 1 and 50% to detector 2. In other words, there is a special kind of physics of observation in quantum theory. Observation has a special effect in the world. So this is on the Copenhagen or any so-called collapse theory. Observation has a special role in the world. It has special physics. Anyone who says that the wave function collapses or wonders about what happens during collapse or why it collapses and so on, these people believe in alternatives to the multiverse. But on the other hand, proponents of the Everett way of understanding quantum theory, the realistic way of understanding quantum theory, the literal reading of the equations of quantum theory, is to say that no such collapse happens. Observation has no special role. Observation does not cause the collapse of the wave function. There is nothing special about observations on this view. The so-called measurement problem, as it's sometimes called, is solved. It dissolves away by saying there is no special physics of measurement. So when it comes to the inner workings of Parlox's brain, his sense organs going on here, the Everett understanding of this is that both possibilities happen. Both the up and the down paths are followed. And this in fact explains why interference effects occur. The photon is in fact a multiversal object. When the photon encounters the half-silvered mirror, all the universes in which the experiment occurs differentiate into two groups. One in which the photon takes the U path, and another group in which the photon takes the D path. This is the only difference between the two groups of universes. These two universes then recombine at the second half-silvered mirror, just prior to the detectors. And it is the literal collision between these two photons, the photons at the U and the D path, that caused the new recombined photon to set off the detector at detector 1, but not detector 2. Now the key thing here for the year 2075, and for Parlox, and what we're now able to do in the distant future, is that Parlox is in fact able to sense the collision of a photon at either of the regular mirrors, because he has a sense organ. So he is able to observe interference going on prior to it happening. So Parlox's sense organs are part of the experiment. His sense organs are those mirrors, those regular mirrors. He can detect if photons are striking those mirrors. And so he is an observer of the experiment while it's going on. Hitherto, impossible to do because we humans don't have such sense organs. But an artificial general intelligence of the future could have such a sense organ, could build themselves such a sense organ and perform this experiment. According to the collapse interpretation, this should cause the interference effect to be lost because it has been observed. According to those interpretations, i.e. all other interpretations besides the multiverse, observation plays a key role in physics. It causes the collapse of the wave function. At least it is supposed to. So in this view, if we repeat the experiment, we should see half the photons to be detected at 1 and half at 2, no matter what, if Parlox is sensing, that is to say observing them with his sense organs, the regular mirrors. And if indeed the interference fails to occur during this observation experiment, during this interference experiment, and Parlox is observing it, then we have refuted the multiverse theory. This is the sense in which the multiverse is testable. We can refute, we can test, we experimentally test and falsify the multiverse theory. Of course, we have no real alternative, but according to the multiverse account of things, no collapse happens so long as Parlox keeps the information about which mirror he has detected a collision at to himself. Here's what goes on according to literal quantum theory, i.e. according to the multiverse. The photon at the first half-silvered mirror causes the differentiation of the universe into two groups. In half the universes, the photon travels the D path, and Parlox in the D universe detects the collision with the photon. In the other half of the universes, Parlox detects the photons having travelled the U path. Parlox himself actually splits into two separate versions. In either case, Parlox U or Parlox D, in whichever universe, he can record and transmit back to David an intermediate result and say, I can testify that I have observed a photon travelling along one and only one path. It must be the same message in either case. Now the distances D and U are long, and it takes light some time to traverse this path. So Parlox does indeed have time to do all this because he's got a fast brain, remember. But very soon after he sends that message, the message that says, I have detected the photon striking one of my mirrors, and only one of my mirrors, he then sends another message. And he repeats the experiment again and again, as good scientists do, sending message after message back to David, who's part of the experiment. If the messages went something like this, I have detected the photon at one and only one mirror. Then the next message comes, I have detected the photon at detector 2, and then I have detected the photon at one and only one mirror. I have detected the photon at detector 1. I have detected the photon at one and only one mirror. I have detected the photon at detector 2, and so on. In other words, roughly half the time detector 1 is activated and half the time detector 2 is, because the photon only ever takes one path, either the U or the D path. It does not take both paths simultaneously. If this was to happen, the multiverse is refuted. However, if the message was to run this way, I have detected the photon at one and only one mirror. Time delay. I have detected the photon at detector 2, and then I have detected the photon at one and only one mirror. Time delay. I have detected the photon at detector 2, etc., it keeps on detecting it at detector 2, then interference has happened, despite the fact the photon was observed at only ever one of the mirrors. What this means is that the act of observing the photon has not collapsed the wave function. And though the photon was detected at only one mirror, something travelled along the other path, in another universe, shoving aside the photon each time. And this collision forced the recombined photon to travel always into detector 2. Now, it's crucially important that Parlox tells no one which mirror he observed the photon strike, because this ruins the experiment. It ruins the experiment because once he says, I detect the photon having struck only one mirror, and that is the mirror corresponding to the U path, this means that the universes have differentiated still further and cannot come together again to interfere. They cannot become fungible once more. The interference can happen if, and only if, the only thing that is different between them is the path of this single photon. If other things start to change, like for example, Parlox sends David a message that the D path was the one travelled, then David also knows in which universe he and Parlox are in, and that is a difference in that universe outside the experiment. This is called decoherence, by the way. Decoherence is where information is leaked out of the experiment into the world, differentiating the universes. Moreover, the message itself will carry different information in the two universes, making them quite different and increasingly different as the energy of the message, as it travels back to the Earth, collides with objects in the solar system. We need to keep the differences only and exclusively inside of Parlox's mind, and effectively this entire apparatus is in Parlox's mind or brain, shielded as it were from the rest of physical reality. This might seem awfully contrived. This might seem bizarre. What on earth are we doing in the year 2075? Why do I have artificial general intelligence? Don't blame the multiverse theory. This bizarre way of testing the multiverse is not the fault of the multiverse theory. It's the fault of the so-called mainstream Copenhagen interpretations or any of the collapse models. They're the weird theory that requires a weird test to refute. That's all. It is those theories that says there is a special role for observers. And so we need to be able to test this special role of observers. It is observers on that account, on that Copenhagen account, on the collapse models account. It is those theories that say there is a special role for observers. That special role is that the observers collapse the wave function. That's what all other interpretations say. That is the spooky and strange claim. So to rule that out, that's why we need this elaborate method inside of a mind to test the claim that observers or minds or something like that is causing the collapse, the vanishing of all the possibilities except for one. If we can rule out this single universe model by having interference between two universes occur within a single mind, then we refute the observer dependence of quantum theory. With the many worlds idea of Everett, and more precisely Deutsch, who replaced the concept that Everett had of branching of a small number of universes into a larger and larger number, and instead David said, well, that's not quite right. It's not that we start off with a small number and that number gets greater and greater and greater over time as quantum phenomena occur, but rather he said that the number of universes that exist all the way back to the beginning of time are constant in number and began fungible, but then differentiate when the possibilities arise. We conclude that the single universe theory and collapse models can be refuted by this means. The only known explanation is that the multiverse did split or differentiate into two different groups, a U group and a D group. And these universes then interfered with each other in such a way that the photon is only ever detected at detector 2 and never at detector 1, despite the fact it was observed by Parlox at only one of the two mirrors. And this was possible because Parlox really did split into two versions of himself, different only to the extent of observing a single photon along the D path or along the U path. Now, what this might be like to split into two copies that are no longer fungible and then to come back together to have these kind of sense organs is anyone's guess at all, but I guess he was having fun. After all, he did know that he was going to be co-authoring a paper with David Deutsch about the fundamentals of physics, so that must have been pretty exciting. Once the experiment is over, it makes no sense to ask Parlox, which mirror did you actually detect the photon at? Was it the mirror on the D path or the mirror along the U path? Parlox won't be able to say, because the two versions of Parlox, and indeed the whole two groups of universes, have recombined at the second half-silvered mirror. Parlox simply cannot remember, because he split into two different copies. one of whom experienced U and one of whom experienced D, but he only recalls ever having experienced one. This is where language kind of breaks down. He both experienced both and one simultaneously. Very strange. So language somewhat fails to capture what is going on here, but the truth is he was both copies for a very brief amount of time. And again, whether this felt like something special or nothing particularly special, we may be able to interrogate him about that, but he'll never be able to tell us which mirror he detected the photon at once he becomes fungible again, once the two versions of him combine together to become a single version of Parlox once more. So he will, in fact, be the first Earthling ever to have experienced this sensation of knowing he was in two universes at the same time and then becoming one version of himself in one universe again. Now, that's if it all works out as predicted by the multiverse. But what if he does not have this experience of being in and conscious of two different non-fungible universes simultaneously? Well, then the whole experiment would refute the multiverse because observation apparently would collapse the wave function, or better to say, the multiverse itself is simply refuted. The point is, if the experiment works as predicted, there is no way of explaining any of it by recourse to a collapse model where all the universes but one cease to exist. So if indeed the interference fails to happen as predicted, then Parlox's experiment, David Deutsch's experiment, has roundly refuted the multiverse. Quantum theory would then have a hugely open problem about how observation works and why it is so fundamental to the nature of the universe. We would need to develop a new physics of observation and measurement, and physics would become in part, fundamental physics would become in part about us, about people, and how it is that our choice to observe stuff or not can cause the majority of reality to vanish in an act of performing a scientific experiment. When we choose to perform a particular experiment, we're causing the collapse of the wave function, the collapse of all these other realities that come to bear, causing the result of the experiment to be the way it is. Whereas the multiverse just says all those realities really do continue to exist. Whatever the case, the multiverse is eminently testable by this technique and in principle falsifiable. So that's that. After many months of promise, I hope this satisfies some of you on the most contentious point when it comes to the multiverse. Well, perhaps not the most contentious point, one of the most contentious points, namely that the multiverse is a testable theory from a number of different angles. There are experiments possible, and the strange experiment here, again, is not the fault of the multiverse. It's the fault of the collapse models that propose observation as a fundamental thing that affects reality. So we need an experiment that could possibly refute this idea. And David's version of this is different to the one that I've just told. Mine is based entirely on his. Of course, errors are completely mine, but I thought that because we'd already explained the Mach-Zehnder interferometer, I wanted to explain that way of doing this experiment. Now, the way that David does it is via looking at this thing called the Stern-Gulach experiment and a property of subatomic particles called spin. And so rather than attempting to explain all of that, I've stuck with what I hope we're already familiar with if you've been bearing with me through this multiverse series. And on that, this video doesn't quite finish the multiverse series, but for now it does. I have a couple more things to say about the multiverse, but we're going to save those for a more distant episode. For now, I wish to move on to the next chapter, chapter 12, A Physicist's History of Philosophy. And that should be a lot of fun because bizarre as some of the things that we've been talking about during this series have been, like the claim, for example, that your observations can cause vast parts of physical reality to cease to exist. The reason why people, including very smart people, very smart physicists, might come to endorse or insist on such ideas or do very bizarre things like reject the multiverse, is not because of the science, but it's because of their philosophy, bad philosophy. And an overview of bad philosophy by David Deutsch is just the remedy for undoing poor thinking on this point. And it will help us to understand why quantum theory in particular, has a special place in the hearts of many, many philosophers because of this bad philosophy. So the scientific community has sort of treated quantum theory in a way that's somewhat different to the way it treats any other scientific theory. But we'll get on to that. We'll get on to why bad philosophy has come to taint our understanding of quantum theory and hampered progress in quantum theory next time. Until then, bye-bye.